So we're going to look at some simple closed surfaces. And what we mean by simple closed surfaces, it has exactly one interior, no holes, and it's hollow. A ping pong ball is a simple closed surface. And if you think about the ping pong ball and everything, the set of all points at a given distance, the radius from a given point, the center, is a sphere. So they're all the same distance from each other. So let's just look at here. This is a sphere, so everything is the same distance from the center if you look at it, okay? As you look at a circle, a sphere, basketball, anything of that nature, okay? The set of all points on a closed simple surface, along with all interior points, is a solid. So in other words, you kind of make a solid with that. Now, a simple closed surface made up of polygonal regions or faces is a polyhedron. So those things that are made with actual sides are polyhedron. The vertices of the polygon region are the vertices of the polyhedron, and the sides are of each polygon region are the edges. So let's look at an example of that. I'm going to get rid of this shape, and let's just look at this one, okay? So I'm going to kind of rotate it a little bit. So this would be what we would consider a polyhedron because it is made up of polygonal sides, these things with the straight edges here. Now it has different shapes on each side. This blue side right here would be considered a face. It's a triangle face. This yellow side is also a face. I can rotate it and we have a red face and a green face. Okay, so we actually have 1, 2, 3, 4, 5 faces because we have the 2 blue ends, and then we have the 3 that go around that are the rectangular sides. Okay, the edges are these lines here where the faces touch each other. It's where they come together. So the edges, just like where you think about the edge of a room, it's where the floor and the wall come together. So think about that, where you're talking about the edges. Now the vertices are where these points are. These would be considered the vertices. Okay? And I'm going to open this up a little bit. And because what I'm going to do is I'm going to unfold it and lay it out. If I can get it laid out for us. There we go. So this is laid out. So this right here would be considered an edge. This point would be considered a vertice. Okay, so and you'll notice the colors of the different faces. And so that's what we're talking about by the different terminology. A polyhedron in which 2 congruent faces, the bases, lie in parallel planes are bound by parts is called a prism. So if I put this back together, this is actually a prism because I have two parts that are parallel to each other, these two blue ends that are parallel, and they're bound by polyhedron sides, surfaces, and so the blue ends would be my bases, and so this is considered a prism. Now, any of these others, let me go back up here, let me actually change this. This is a prism. We have, this is going to be a prism because I have the two blue bases again. Let me, no, not that. Here is also a prism. So all of these are prisms, even though I've changed the number of sides. Okay? The faces other than the bases are considered the lateral faces. So this is what I was looking at just a few moments ago. So the ends, think about a tent. The ends are going to be the bases, and these other parts are the lateral faces. If the lateral faces are bounded by rectangles, the prism is a right prism. If not, it's an oblique prism. So this is actually a right prism because notice the two bases are bound by rectangles. Same as this. It is bound by rectangles. So in all of these, notice they're bound by rectangles, the base is. Okay? Now, this is still a rectangle. Now, if you notice, this one is not because of the circular part of it. Okay, so we have to be a little bit careful with that. A polyhedron determined by a polygon and a point, not in the plane, is a pyramid. So these right here are prisms because they have bases on the ends. Okay, let me get rid of all those. Okay, and let me come here. This is a prism. I'm sorry, this is a pyramid, not a prism, because it has a base, this blue base, and then it comes up to the top. I'm going to change the shape of the base. It has a base, it's a pentagonal base, but then it comes up to the top. And I'm going to change the height to 10. That way we can see it a little bit better. Okay. So it comes up to a point. And where it comes up to a point, that is going to be a pyramid. Now, this right here, let's see here, this is a base edge and a base edge. The height right here, and I'm going to come over here and draw a line. I'm going to draw a line from here down. Okay, notice I'm drawing a line in the middle here, and I'm going to create a right angle here. So if I look at, nope, don't want to do that. Let's still want to leave that where I had it. So if I kind of rotate this, that right there along that area is my slant height. Okay? It's where I want to measure most of the time at an angle. So it's not the height from the top to the center of my diagram, it's actually at an angle there. So the point is called the apex. So like this right here is our apex. This is our slant height. So we're going to be looking at these different types of pyramids, prisms, that type of thing.